Hello. This is a question that a student wanted me to look at for them. And we're solving for z here. And the question is, solve for z where 6 times the absolute value of 4 minus z is greater than or equal to a negative 30. So one thing to sort of look at here is, since absolute value always has to be positive, and we're looking at this as being greater than negative 30, you can tell right away that the answer is going to be all real numbers, because anything you put in there for z, the absolute value is going to make it positive, and anything that's positive times 6 will always be greater than negative 30. But I'll go ahead and show you how we would solve this one, how we would tackle it. So let's go ahead and look at solving this mathematically. So the first step I would do is divide things by 6. I'm going to divide both sides by 6, and that will give me absolute value of 4 minus z is greater than or equal to a negative 5. So let's see what we're really saying here literally. If we look at a number line, we're saying that, remember, the absolute value gives us the distance between the difference of the two numbers. So what we're really saying here is that for some number z, the distance between z and 4, so if my 4 over here, is negative 5. So really that doesn't make any sense. It's always going to be greater than negative 5. So it's hard to interpret something like this, because it's always going to be greater than negative 5. But we're going to go ahead and solve it anyway and see that we get all real numbers. So we know that that's going to be always greater than or equal to negative 5, because there's no real distance there. Our distances are always greater than negative numbers. How I would do this mathematically is I would turn it into two equations. So let's say that what's inside the absolute values is positive. I would say 4 minus z is greater than or equal to negative 5. Or I would say, what if the thing in absolute values was negative? If it's negative, we would have the opposite of 4 minus z is greater than negative 5. So I turned it into two inequalities now. I'm going to solve these for z. So I'm going to bring, in my first inequality, I'm going to bring the z on over. And I'm going to add 5 to both sides. Let me do this in 2 steps. So I have 4 is greater than or equal to z minus 5. If I add 5 on over, I get z is less than or equal to 9. So there's 1. Or I have this inequality over here. I'm going to go ahead and distribute that minus on through. So I get minus 4 plus z is greater than or equal to negative 5. I'm going to add that 4 on over. So I get z is greater than or equal to a negative 1. So now I'm looking at this 4 connection, because we're looking at this being greater than or equal to the negative 5. So I need to take the union of both these things. So if I look at these bit by bit, the first one, I'm running out of room here, but the first one is this on my number line. Because, well, z is greater than or equal to 9. Z is less than 9. Sorry about that. So here's 9. Z would have to be this way. This way. All right, well, the second thing says that z has to be greater than or equal to negative 1. There's my negative 1, and so I go to the right forever. So now I look at where the red and the green, where those are, and notice that it's everywhere. So that or connector means take both of them. If it was an and, I would take what's in between, but this is an or connector. So I need to take all real numbers, so negative infinity to infinity,